Hello, students. Our paper today is Mathematics 9709/06, Statistics 0390/06, Paper 6, Probability and Statistics 1, taken in May, June 2005. Now, our question of interest is question 6, which reads, tire pressures on a certain type of car independently follow a normal distribution with mean 1.9 bars and standard deviation 0.15 bars. Find the probability that all four tires on a car of this type have pressures between 1.82 bars and 1.92 bars. 5 marks. 2. Safety regulations state that the pressures must be between 1.9 minus B bars and 1.9 plus B bars. It is known that 80% of tires are within these safety limits. Find the safety limits. Remarks. Now, this is the question of interest, and we straight away get to the solution. Well, the pressures on a certain type of car independently follow a normal distribution with the mean 1.9 bars and standard deviation 0.15 bars. Find the probability that all four tires on a car of this type have pressures between 1.82 bars and 1.92 bars. Sorry. This means that first we are going to find two Z values. The first Z value is where, because we are told, okay, that find that all four have pressure. So if pressure is X, then we are going to have, we are asked to find that it lies between this. That it lies between 1.82 and 1.92. That's what we are asked. So if the pressure which is represented by X lies between 1.82 and 1.92, in effect what it implies is that first we are going to get the first value of Z. That first value of Z should give us 1.82 minus 1.9 over 0.15 should give us that value of Z. The second value of Z should give us 1.92 minus 1.9 over 0.15. So the first case should give us, this is negative, yeah? So it should give us negative 0.08 over 0.15. And that gives us negative, if you work it out using a calculator, 533, 3 recurring, it's a negative. Then the second option gives us 0.02 over 0.15, and that is 0.13 recurring again, 3 recurring. So those are the two values of Z that we have. So for us to get the area under that curve, because we looks like this, looks like that. So if the mean is here is 1.9, if this is 1.9 as the mean, then 1.8 will be here and 1.92 will be beyond here. So the area that we want is this shaded part. You want the area of the shaded part. The shaded part. So to get that area, we'll get phi of this and phi of this, and that should give us the area. So phi of this, we start with, actually it's phi of that, how will the area be? Because now, if we have here to be 1.9, if we have here to be 1.9, then it means that for us to get this area, we would first need to get the area from, we get the area from, just a moment. So in this, if this is 1.9 and this is 1.92, this is 1.82, which is this other end. For us to get this area, we would have to subtract the area from here to here. We would have to subtract the area, the entire area from here coming this end, which is represented by phi of 0.13. 3 is recurring, minus the area from here, actually from here to here, minus the area from here to here. The area from here to here is given by this. So it's minus phi of, minus 0.5333. This implies that we have phi of 0.1333 minus 1 minus phi of 0.533, like that. That's what we have. And that, what that means is that we then set out to read these values from the tables. We read the corresponding, the probability that corresponds to this Z value, and also the probability that corresponds to this Z value. So we read out those values as, the values are, for phi 0.1333, the value we have seen is 0.5529 minus, in bracket, 1 minus phi of 0.533 is 0.7029, like that. So this means that if we work it out, it's going to be 0.5529 plus, because minus this minus that, 0.7029 minus 1. That should give you an answer of 0.256 as the answer. 0.256 as the answer. But then we are asked, find the probability that all 4 tires on a car of this type have pressures between that. All four. So in that case, we raise this probability. So probability that all 4, 0.256 raised to power 4. And that gives me, if you raise 0.2456 to power 4, you should get 0.00429. A value close to that here. And that's the answer to part 1. That's the answer to Roman 1. So that was Roman 1. Roman 2, we are here. Roman 2. Safety regulations state that the pressure must be between 1.9 minus B bars and 1.9 plus B bars. It is known that 80% of tires are within these limits, safety limits. Find the safety limits. So again, we just do the same thing we did by getting two Z values, and the first Z value, okay, what we get is we say that 1.9 minus b minus 1.9 all over the standard deviation, which is 0.15. Is equal to, we are told that 80% of tires are within this safety limit. Sorry. So it means that we can use that probability of 80% to get the corresponding value of Z here, then work out the value of B. So the corresponding value of Z corresponds, the value that corresponds to 80%, we read it as, the same way we drew it here. It just means that if that's the curve, and then at this point we say this is the mean, which is 1.9, and then here we say is B. Then it will then mean that probability that Z is greater, probability that Z is greater, will be given by this shaded part here, because here we have this is B and this minus B minus B. So it means this shaded part here is 0.8. If that is 0.8, we are left with 20%, which takes this 0.1 and this 0.1. So in effect, a probability that Z, we take a positive value, we take that 1 minus 1.9 minus B minus 1.9 will be equal to 0.1. So we check the value of the value that corresponds to that probability, the Z value that corresponds to this probability, we check within the table, then equate it to this for us to get B. But in our standard model, I'll show you how that works in our standard normal tables. But if you do that, then you should find that the Z value is 1.282. I'm about to show you that. So that's what you equate to 1.9 minus B, 1.9 minus B, 1.9 plus B. Let's talk about 1.9 plus B minus 1.9 plus B minus 1.9 over 0.1 over 0.15. So this is 1.282 is equal to B over 0.15, implying that B is 1.282 times 0.15, which gives us B is 1.28 times 0.15. So that this now should be the upper limit. If you multiply this by this, then it should give you the upper limit, what we have there. So upon multiplying that, you should get 2.09. That should give you 2.09 on the upper hand. And if you are to get, just a minute. This gives you, this should give you 0.1923. And what we are saying is that this part here is 1.9 plus b, and this part here is 1.9 minus b. Yeah, that's what we have. So if we have b to be this, it will then imply that the upper bound, the upper value will be 1.9 plus 0.1923, or 1.9 minus 0.1923. Those are the answers. So those values should give us 1.71. This should give me 1.71, and this should give me 2.09. And those are the answers to that particular question. You can go over it once again, just to understand why we took certain steps up to that point. See you in the next video.